We have one more talk before the break with Brian Doyle, who is a staff engineer at Pixee, a replicated customer who agreed to come on here and talk a little bit about how they're approaching using replicated to simplify enterprise deployments. Brian, I know we're a little bit early. Are you ready?
Sure, I'm ready.
Awesome. I'll stop sharing and you can go ahead and share and get started.
Okay. Thank you, Mark, and thank you for inviting me to talk today. Today, I'm going to talk to you about how we're using Replicated at Pixee, a little bit about why we chose Replicated, the capabilities that we take advantage of that we really enjoy, specifically around the embedded cluster, and how we test using Compatibility Matrix. I'm going to talk a little bit about a case study with a recent customer deployment here, and then some best practices, as well as some things we're looking forward to as a design partner today. Just to start, I'll introduce myself. So my name is Brian Doyle, and I've got about 20 years experience in development or development management roles across a number of different industry verticals, from consulting to video games, defense, health tech, e-commerce, financial services, and now application security. I've worked for large Fortune 500 enterprises as well as early stage startups. So I've had the, I think, unique perspective of being on both sides of the table when it comes to building, buying, and selling to enterprises when it comes to software. And a little bit about Pixee. So at Pixee, we're aiming to deliver to you an automated product security engineer. We do that by producing triage and actual code fixes for your application security vulnerabilities. And we do that by combining the latest in AI capabilities as well as utilizing our longstanding security expertise. And we do that with appropriate guardrails to ensure defensible quality triage results and actual code fixes. A lot of our customers, they have very strict or established security practices and policies, oftentimes dedicated teams. And so these security requirements often lead to a need for on-premises installations. And what we see there, oftentimes, it comes in the forms of these kinds of challenges. Every customer is unique for us in our experience, but they have these kind of common buckets around these strict security requirements that are oftentimes similar, but oftentimes also very different. There's operational complexity that comes with running applications, especially when we're talking about Kubernetes and putting that into an environment. That presents a challenge also often for customers in terms of this operational overhead. And then there's a lot of variability, right? So every customer is unique. They have a different infrastructure provider. They have different methods, different policies, different team structures. Even the human component can introduce some variability there that you have to be thoughtful and aware of. So with these challenges, we went looking for a solution. So I'll tell you, we tried it ourselves first. What we found was we produced a very optimized experience, in our opinion, for what we were most familiar with. But as soon as we started talking to the next customer, they had something different, right? So we needed something that would help us tackle some of this variability and this complexity that came with operating an application like ours in a cluster like Kubernetes. And we found Replicated, and it solved a lot of these problems for us, right? It simplified these operations for installing and managing clusters in our application in a cluster. It gave us some enterprise-ready features around air gap support, some security features out of the box, as well as the ability to deliver our software in a way that was much more accessible to a lot of these customers. And of course, it comes on top of this proven technology around Kubernetes itself and the enterprise support that we take advantage of and are able to use with Replicated, right? So, one aspect of Replicated that we use quite a bit is the embedded cluster. So if you're not familiar with the embedded cluster, it is a way for you to install your software. It comes with an embedded Kubernetes distribution, the COTS and troubleshoot frameworks, and a web-based UI for installing and configuring your application. And for us, from a business perspective, this has been extremely valuable. It's allowed us to deploy in minutes rather than weeks. I think our current best time is around 30 minutes, actually. So it's been great. That's not always the case. There are often challenges, and I'll get into that with our case study later. There are a lot of security features built in around working with proxies and PKI and helping manage security, firewall exclusions that are needed to pull our images, for example. And then this part about scalable revenue is we have this packaged configuration that we can push out to customers in multiple different kinds of environments, allowing us to quickly be able to service customers with a variety of different across a variety of different deployment landscapes with the same packaged solution and configuration that allows us to do that without having a lot of support overhead from our perspective. So one thing that we did find, I mentioned the embedded cluster and the web UI and the GUI that comes with that. It is fantastic. We love it. But what we've also found is that working with customers, some customers have very interesting requirements around, let's say, destroying their dev environment every day. So when we're installing it as a proof of value, a trial installation, they have to reinstall every day to get going, and they've demanded some more automation capabilities. Make that easier for us. We don't want to have to go through and do this sort of quick ops flow every day when we want the same thing every time. With that, we said, okay, well, let's see what we can do. Replicated does offer a headless installation. And so we went with that headless installation with our customer, and we said, okay, let's get our configuration ready. We exported that through the instructions that we have available to us. We built up a couple of scripts to help them manage that quickly. And then we went back into our own config and said, hey, there are these things that we want to be able to do in this headless fashion. Our config right now is relatively complex for that. Let's see if we can't pare this down and optimize it a little bit. So the headless installation has been really helpful for those kinds of clients that said, hey, we need more automation. We need better ways to do this quickly and repeatably and reliably. Another thing to say about it, like, the headless installation is great for those customers that have these large scale deployments that need to push it out in multiple different places, or they have pipelines that we need to integrate with. And it does require some strong technical expertise to be able to do that, as well as having that pre-configured template for configuration. The traditional embedded cluster GUI installation, great for your very first time installation, for quick feedback, very reduced barrier to entry in terms of the technical aspects of that. So they're both great options. What we found is, like, we use them both, right? And here's really just what we go through when we think about when we need which one. Now, beyond the installation for the embedded cluster, there are other aspects of the replicated platform that we take advantage of quite a bit. And I'll talk a bit about those more individually. Support bundles and pre-flight checks. These are great for collecting information about either what's available in the environment, whether you're going to be able to install successfully or not, as well as when your software is operating, what's happening inside that cluster that you may not have visibility into in real time. What has happened historically through logs, or what are your integrations doing there? If they're working correctly or not. License and channel management. So you have this one-click customer management with Replicated. You can set the channel that you want them to install and be able to update through. If you have multiple versions of your application, let's say, or different tiers, as well as the license management for being able to support different types of customers. And then I'll talk about the compatibility matrix and how we use that as a capability provided by Replicated to test our application as we make changes, and making sure that we have full compatibility across the varying landscape of types of deployments. A little bit more about the license strategy. I mentioned, like, having different types of customers. What we find is we use a trial license quite a bit for users that want to trial our software. They want to come in and have a short engagement, see the proof of value before we sell them more of our software or bring them on as a customer. And then internally, we use a lot of development licenses to test our deployments, or new features, or new config and capabilities. And then, of course, for our paid customers, we have the paid license there. And then on to the compatibility matrix. So this is a capability provided by Replicated that allows you to spin up a cluster very quickly and then do your installation and run, and have it available to you. So you then can run another battery of tests. And that's what we do. Like, every deployment that we create, every release that we create goes through a workflow. And there's a screenshot here of a portion of our GitHub workflow-based CI pipeline that takes our release. It uses the compatibility matrix to deploy our release there, install it. We run some support bundles there to make sure our integrations are working. And then we have some, manual test cases that we also can run when we need to against those clusters that are operating in those different environments, whether it be a VM base using K3s, or an AWS EKS installation, or GKE or AKS. There's a lot of different capabilities there for doing your installation against these different platforms, which for us has been absolutely crucial in terms of testing that compatibility, finding issues before we even make a release available to customers, before we promote that release to the channel where our customers are consuming our updates and our application. And now I'm going to talk a little bit about a case study for a recent installation that we've had. We have a customer, the global financial institution. Here's a very simplified version of some of the networking challenges or the environmental challenges that we saw in their deployment. So they have a firewall. So anything that we want to reach out to the internet or to come into this environment has to be allowed there. So where that really comes into play is we needed to pull a few images, right? So we needed to set some exceptions. Our application needs to speak out to the internet in some ways. And so that firewall we had to have them make exceptions for their firewall. And so that was one of the challenges that we saw. As well as internally, they have a private key infrastructure and a proxy server. So all traffic going from inside the network to the outside network has to route through a proxy. That proxy is using this private key infrastructure to secure requests. So our service needed to be able to validate that private key, their certificate authority, as well as route through the proxies. We had to be able to speak to a proxy and make sure that would work correctly for all of our external egress needs. So with those things in mind, we had these challenges. The first challenge the first question really we had to ask is, how are we going to install? They had multiple different environments available with different kinds of security protections and policies in place. And having the flexibility to replicate it to do a Helm install versus an embedded cluster allowed us to pick the right choice at the right time for the right environment. And working with our client, we figured out, okay, let's do an embedded cluster install in this particular environment with these particular constraints. We know we can be more successful that way, with the eye towards a different, higher production environment that would require a Helm install later. So having those options right away was a big plus for us. When it came to working with this private key infrastructure, the embedded cluster and the COTS framework provide this template function that allow you to pull private CA certificates from the host, which they provided, and allowed us to take that information and bring it into our application so that we could quickly take advantage of that available CA cert and use it to secure our traffic from our application all the way into our application logic down through and out to the internet. Those firewall exceptions that we needed were very simplified because we have the replicated image proxy in place, allowing us to say, hey, there's a small set of well-known domains in that IP address space that you need to allow. And once we have that, basically all of our application will work correctly. And then the proxy support came also through that same COTS framework provided via the embedded cluster. The ability to set up an HTTPS proxy config on install and then provide that to our application. They also had an SE Linux requirement. So it wasn't available at the time. We did get an exception, but we now see that is available in the embedded cluster, the ability to provide an SE Linux configuration that will allow the embedded cluster to operate successfully. And the last thing here to say is we were offset from a time zone perspective and had limited visibility into this environment. So we had to be very efficient with our time. We had very little overlap with our customer from day to day. So having the ability to rapidly collect information about what's happening or what has happened, as well as to check our configuration prior to installation, was invaluable. It saved us a lot of time, made us a lot more efficient when it came to being able to work with our customer the way we needed to. So with that, we learned a number of things actually, and I kind of distilled them down here. That pre-flight validation is crucial. Being able to write pre-flight checks yourself that you can then use to validate your integrations before you do your installation. Verifying things like the system requirements, the network connectivity, all the way into the application itself. Especially using that headless install method, we can run our application pre-flights as part of the installation and see, do we have the right level of connectivity to our external dependencies that we need? Are we able to reach them? Are they able to give us data back correctly, et cetera? Here's a note about configuration management. Maintaining clear documentation is really important, especially when you're dealing with customers with a variety of different kinds of deployment environments. You may go one day to an EKS deployment, the next day to an embedded cluster, the next day to an AKS deployment, and having clear documentation about what is needed or specific in those environments is really helpful, not just for your customers, but also for you as a vendor supporting them, being able to describe, here's what you need, here's how you can be successful here. Monitoring integrations and operations. Again, this is about support bundles really for us. Generating a support bundle that can test your integrations. For example, we use a lot of LLMs and AI models. And so we have support bundles that will do things like go check, can we, one, connect to the model? Two, can we get a valid response from it? And three, did we notice anything about that request, such as are we seeing any token rate limiting happening, right? Support bundle has been invaluable for helping us find and check configuration outside of our application that's important for our success or the success of our customers. Make sure that they have the right quota set in those areas. The last thing here is about mirroring complexity. Excuse me. In this environment, we had this proxy, we had this private CA, we had this firewall, we had all this stuff that we discovered and needed to work with. Now, the compatibility matrix can go a long way in helping you build a test environment, but what we found is we needed something even more. And so, when you find those very complex environments, doing what you can to mirror that in a way that gives you like a lab environment to test with is very important. It's very important for us. It made us much more efficient. And also, it gives us something to layer into our testing pipeline too, to say, hey, we know we have these customers with these complex environments. Can we still see that we don't have any regression in this area with these lab tests? The last thing I'll say here is about what we're looking forward to. As an early adopter for the new V3 embedded cluster, we're acting as a design partner with Replicated. We're looking forward to seeing some of the new capabilities that are coming with it. To do that, we work with them directly through regular feedback sessions. We're beta testing these new installers with the embedded cluster. And then we're providing feedback directly from our experience with customer installations to what kinds of things do we need, what is a priority for us. And we're really excited about the new capabilities coming, especially around further automation when it comes to installing and even upgrading embedded clusters. So looking forward, a couple of recommendations if you're thinking about using the embedded cluster or if you're just starting. Take advantage of the compatibility matrix. It's a great way for you to verify that you don't have any hidden edge cases around the way your application works or what you need to be available in a particular deployment type or environment. Plan for both installation types. This is about Helm and embedded cluster. We found that different customers have different demands and they need certain flexibility in certain cases, as well as that automation that they're going to expect in certain ways. So having the ability to deploy with Helm or embedded cluster together, it gives you that flexibility. And it really enables a lot of different types of installations. And then lastly, engage as a design partner. I know Replicated is always looking for more feedback, and they're open to that through a design partnership. And I think you can talk to Alex about that specifically. And that's it for me.
Thanks, Brian. Definitely appreciate you hopping on and sharing all that. And I know you've worked really closely with some of our team on you mentioned the V3 of embedded cluster and some of the stuff we're doing there. Yeah, I really appreciate you putting the time and joining us and sharing that with everybody.